Hey folks, we've got on the docket today 4 students that actually got through our engineering physics program as undergrads and are now doing really great things. We've got Caroline, we've got Jen, we've got Hillary, we've got Allie. And I just thought we'd start off and just let each one of the 4 just sort of introduce themselves, and maybe first start off just talking about, why they chose mines as their undergraduate program of study, what they maybe enjoyed about engineering physics, some of the challenges they faced, some of the achievements they had. And they just sort of talk about things from an undergraduate perspective first. And we'll go from there. I'm going to see if Allie, are you with us yet? I don't see Allie.
I think I saw her joining.
There she is. I'll make Allie a co-host as well. So Allie and Jen and Caroline and Hillary can all be co-hosts. So if you want to share something, you're welcome to share. But hey, Allie, you want to start us off? We'll start with the first letter of the alphabet, A.
Sure. So I chose mines partly because I'm from Colorado and I really wanted to stay in state. I really liked the small feel of it. And I actually had a really hard time making up my mind where I wanted to go to school, and shadowed some classes at mines, specifically in the physics department, and really loved the feel of mines. So for me, it was all about the people and how the classes were taught. And then I chose physics because I liked how general it was. I really didn't know what I wanted to do. When I started, I thought I might want to do aero or maybe solar cells, or I was kind of all over the board, really. Let's see, Chuck, did I answer all of the questions yet? Or what were the other questions you wanted us to start with?
You also rode horses for a while when you were here.
Yeah, I actually started the Mines Equestrian team, and it's still going today. I was a member of the Society of Physics Students, Society of Women in Physics, and SWE while I was there.
And then you wandered off one summer to Germany.
Yeah. So I decided to do my master's in mechanical engineering. And between my mechanical engineering master's and the end of my physics degree, Chuck actually helped me find a really cool internship at the DLR in Germany. So the DLR is a little bit like German NASA. They do a lot of research into fighters and weather and pretty much anything that NASA does for the US, but in Germany. And my project there involves studying high lift devices on basically their F-16 replacement they were trying to come up with. So that was a really cool project and a great start to my career.
Yeah, and you did that. Wasn't that between your junior and senior year? Or was that after your senior year?
No, that was between senior and master year.
Because I want to say, correct me if I'm wrong, but didn't you do some work in computational fluid dynamics?
Yes, yes, I did.
I mean, pretty sophisticated. So you had to have a good foundation before you were selected for that, because I remember it was really, really competitive. And
yep, yeah, it required a lot of understanding of fluid dynamics before I was capable of doing that internship.
Yeah, so that was one that you had to actually have some, solid experience and background prior to joining, and not just, hey, come in and help us clean the test tube, so to speak. Anybody can do this.
Yep, and then, gosh, Dominic Martinez went the next year too, so we've got a good connection there with the DLR.
Yeah. And this past year, we weren't able to send anybody just due to the COVID restrictions and, travel. It was sort of a mess, but
Yep.
we might be able to look forward to something for next summer. Okay. Hey, Caroline, are you with us? I can't see all the pictures.
I am, yes.
Oh my goodness.
Really happy to be here.
You look happy today.
Yeah. So I had put together a couple of slides that honestly are more talking points. They kind of ran through all the questions you had sent us. So I will go off of those and I can show them later when we get to the career part, if that works. But in terms of why I chose mines, I'm from Texas originally. I wanted to be a geologist at first, and it took me about a semester to figure out that that wasn't the right move for me. But I really loved Phys 1 my first semester, and I really enjoyed physics in high school. And so that's kind of, then after reaching out to some of the professors in the physics department and getting to know some other students in there, that's how I landed on choosing physics as my program. And I guess more mines generally and the physics department. I always wanted a small field in the college that I went to, and I wanted the chance to know all my professors and know most of the people in my classes. And so both of those things were what drew me first to mines and then also just to the physics department itself. So that's how I landed at mines and how I landed in physics. And then while I was there, I, like Allie, was also in SPS and then was in Society of Women in Physics and got to be president of that for a little while, which was really great. And some of the big memories that stand out there were the 2 QIPs that I went to, which were fantastic and remain some of my best memories in terms of networking and knowing what all people are doing out there with their physics degrees. And then I was also a Phys 1 TA for a semester. And that was a really great experience too.
Yeah, the QWIP, which is CUWIP, is the Conference for Undergraduate Women in Physics. It's open to everybody, but it's usually in January of each year. And hopefully we'll be able to send a small tribe or a large tribe out there this year. They're regional. I forget where the regional one is this year. I want to say it might be Arizona, but I might be mistaken. But you went to 2 of those.
I did. Yeah, I got
Gosh.
lucky.
It's like the Oreos with the double stuffing.
That's right.
Double good.
Definitely.
Okay. Hey, how about Hillary?
All right. Yeah, so thanks for having me. It's great to see some familiar names on the Zoom boxes here. So reasons why I chose mines. I am also from Colorado. I grew up in Greeley. I think I always wanted to do something in engineering or STEM for my career, but I actually chose mines for a little bit of an unconventional reason. I got a track scholarship. So athletics paid for some of my education. And then of course, being in state, it was a very good deal to go to mines. And so when I got there, some of what the other folks have already said kind of resonated with me, just the community feel of the place. It's a very personal campus in a lot of ways. And then as far as the physics department specifically, I think that I came in as a civil engineering major my first semester, but I quickly learned that field wasn't for me. And I was also a TA for Physics 100 and then subsequently Physics 200. I was a TA for Physics 200 for even longer, but being a TA for Physics 100 really, I got to know the department better, and I ended up changing my major, I think, after TAing for that one semester, because it was a really great experience. And while I was at Mines, so the engineering physics degree really gives you a good opportunity to take advantage of the flexibility of the degree. So you'll see from the different careers that we all have that you can do a lot with it. And I'm still in touch with folks from my graduating class, and some of them have gone to get PhDs in totally different fields. Some of them have gone on to industry, and it's really cool to see what everyone's doing. But just the well-rounded curriculum of Mines in general for an engineering school, especially. So I was part of the McBride Honors Program at Mines. So I did my minor in public policy. there. And then I was also a member of SWE and SPS. I think that QWIPs did not quite happen until maybe the year after I graduated. I was not able to go to one of those, but I've been on a panel at one now, but they're a great opportunity. And so so I was the VP of communications for SWE. And then of course I was on the track and field team the whole time I was there. It was a major part of my experience at Mines. And then my TAing experience. During the summer, I did a research REU up at CU Boulder. This was the summer after my junior year. So I did a research experience in the electrical engineering department, actually, where I worked on building transistors in a clean room. And then shortly thereafter, decided to become a theoretical physicist. But that was a good opportunity as well. And Mines really connected me to those places. And I think that is all the things I wrote down for my 3 reasons. Yeah, did I miss anything?
Oh no, I've got something, but we'll get to it later.
Okay.
You like math,
Yes, I do a lot of math.
or you like math, or you like math. Hey, Jen, we'll give you the floor.
Hey everyone, thanks for inviting me to this. It's really awesome to be back virtually and see everyone. Yeah, so kind of similar to what other people were saying about like why Mines. I think a big part of it was this like small feel of it. I grew up in Colorado also, and kind of wanted to stay somewhat local and have something small. I think one thing I really like about Mines is there's a big focus on like a lot of the, kind of meat and potatoes classes and not a bunch of like extra electives that you have to take. I liked that a lot. I also had a family connection to Mine, so that played into it a little bit. And so when I started, I actually was undeclared. I didn't really know what I wanted to do. I just knew that I very much liked, science and engineering, but wasn't sure what exactly I wanted to pick. Partway through my first year, I decided to try out the metallurgy and material science department. And I did like the summer field session with them. Got to tour some cool mines. I lived in a mine and things like that. But I kind of pretty quickly realized that wasn't really for me. And I wanted a little bit more kind of like the foundational physics education that I wasn't really seeing too much in like that more engineering focused department. So that's why I did physics. And also like, I think someone mentioned like that it's very general. And so it opens up a lot of possibilities. That was another reason. And then, yeah, I also TA'd for physics too, I think for 4 semesters, if I'm remembering correctly, which was a really great experience. That was really awesome to be able to do that. And then I did also a summer REU. I did it locally with Professor Carr and a senior design project and all that. That was a really great experience for when I left to go do a PhD afterwards.
I'm surprised all 4 of you had a chance to actually go to class. Sounds like you were involved in so many extracurricular activities that classes just sort of came and went as you could fit them in. Hey, so you've all had interest in doing things after your undergraduate degrees in terms of your education, either going to graduate school or wait, I think Caroline, you're doing some stuff in computer science right now, or exploring something in computer science. But I guess the next question is, what actually sort of motivated you folks to actually pursue advanced studies, an advanced degree? And, for our folks that are in graduate school here, I guess they've already made that decision, but, once you start, part of what you want to do is persist and get through the whole program because, you can have your challenges at any moments, but, what sort of motivated you folks to go and get an advanced degree? And we'll go back with Allie again.
Sorry. Well, one of the things for me was that I I hadn't really decided what I wanted to do by the end of my senior year. But I was starting to realize that I needed to know more of the mechanical side of engineering to go into aerospace. So for me, the 5-year master's program was kind of just right. I was a little bit done with school by the end of my senior year and ready to move on, but also felt like I needed to know more. So the 5-year was kind of a good balance for me to learn what I needed to start my job, but also to stay, to get out of school and start experiencing the real world a little bit.
You did the 5-year program here at Mines.
Yeah.
And did you like the selection of courses you had the opportunity to take?
Mostly, it was more on the mechanical engineering side. The fluids department is not as strong as it could be, but there were still some interesting classes to take. Combustion and viscous flow and a couple other aero classes were pretty interesting.
Yeah, so you sort of tailored you were able to tailor your studies to your current career path, which worked out pretty well.
Yep.
But you don't always know when you're taking your classes, how is this going to actually play into the so-called real world?
Yeah, and some of the things that I took were not very applicable, but still learned a lot about problem solving, and they're still useful.
Yeah, yeah. Hey, so Caroline, what are you up to now? I know you said that you were doing some stuff with computer science. Is that correct?
That's correct. Yeah, computer science is kind of an auxiliary interest that I think I developed over my time at Mines. Kind of started with the Python computing class that I don't remember what the exact name was, but I remember it was the sub for thermo at the time, another option you could take. But getting introduced to Python in that class was really awesome. And then just our extensive use of Mathematica and MATLAB throughout all the physics classes. I really love getting to do that side of things, and really looked forward to that part of the homeworks and the projects and labs we did. And then in addition to that, in my summer between my junior and senior years, I interned with Lockheed Martin on the OSIRIS-REx program, which is it's an asteroid sample return mission that's actually on its way back to Earth now with pieces of an asteroid, so that's kind of cool. But that summer, my whole project was to create a set of modules of Python modules for checking the flight rules, which are essentially the 10 commandments of the spacecraft and rules that you can't break with it, or otherwise you could have catastrophic consequences. And so my job was to develop an automated method to go through and verify that anything we sent to the spacecraft was going to be safe for it to execute. And so I already kind of enjoyed the programming piece of what we were doing at Mines, and then getting to see that applied in the context of aerospace was really exciting for me. And I kind of knew at that point that I wanted to go further down the road of computer science to some degree. And so I chose to wait a little bit longer and spend some time working to make sure that's what I really wanted to do, and to also see if anything else caught my interest more. But now, having worked for close to 3 years, I've seen where its utility is across the board, and I've seen lots of ways in my work that it could be useful. So I just applied in this spring and I got accepted. So I'm at UT now, and I'm in my first semester, and long road ahead, but it's going great.
So you're going to be focusing on software or hardware or some other aspect of computer science that you or your workplace feels that's important?
Right. It's more general at this point. I haven't really honed in specifically on where I'll go with it, but there are just a multitude. I'm doing this all personally. It's actually nothing going through my work, but I've seen a number of ways that coincide with my interests that I could use it to make things better in my role for our team and for the crew on board the station. So that's kind of where I'm at with it.
Oh, so you're like taking these classes after your work hours.
Yes, yes,
So you're not like working 3 days a week and going to school 2 days a week is actually.
right. Yeah, I'm still working full time and then doing this. Unfortunately, the program I'm doing is almost completely asynchronous in terms of the class time. So it's all video that I can watch after the fact. And then we just have, deadlines for assignments and things. But yeah, it integrates pretty well in my work schedule.
Yeah, well, good for you. Good for you. Let us know when you graduate. We'll show up.
It'll be a while, but I'll get there
It's
eventually.
okay. You're on the path. Hey, Hillary, you sort of went across the pond, so to speak, and studied math for a while. And I don't know if that was like a fun vacation for you or if that was part of your graduate studies, but tell us about that. It was a really unique opportunity and a really special experience, I think.
Yeah, it really was. So after I graduated from Mines with my bachelor's degree, I went to the University of Cambridge in the UK and I did a master's degree there. And during my experience in McBride, I was able to go abroad a few times, but specifically with McBride on a trip. And I really wanted to see, I wanted to live abroad and I wanted to see what else, what other kinds of opportunities there were. And so I applied to a few different things. I applied to some master's programs in Germany as well. But this one, so the UK has 1-year master's degrees. And this one specifically was in applied mathematics and theoretical physics. So it's at the University of Cambridge, and Stephen Hawking was still there at the time. I never really got to see him, but I got to creep around his office. So it's all coursework. The British system is very different from the US system in that there's very little structure. So you go to lectures and then you kind of just do everything, do the problems on your own, and then you have 1 or 2 days of exams at the end of the year, and you hope that you make it. So that was very tough for me, but it was really an amazing experience because it really opened my eyes to all of the things that you can do as a theoretical physicist. So it was specifically that kind of career track. So I took a lot of classes in quantum field theory and high energy physics and condensed matter physics. And it was, I would say Mines prepared me very well for that, but it was still very difficult doing those courses and being in kind of this new system where there's very little like guardrails, so to speak. But it was really a cool opportunity. So I earned a master's degree there. And then I came back to the US to pursue the PhD. So as far as why I wanted to do advanced study, I guess in some sense, I just like school. I mean, I'm a professor now. So at some point I just, I like reading books and learning things that way. And I've always been kind of a person who did something because it was just really intellectually hard for me, and it's gotten me into trouble sometimes, but I mean, it's why I pursued physics. It was, the first class that I really struggled in at Mines. So I thought maybe I should do that and try to do it the best I can. And then I did this advanced degree program, and it just seemed like at the time, theoretical physics is the hardest thing you can do. And of course, other things are very hard as well, and that's not the right way to think about it, but that's what I thought at the time. And I thought I have to master this challenge. But really, ultimately, I just wanted to know more about quantum mechanics, and I'm still learning about quantum mechanics today. And so in some sense, it was for this greater challenge and for this sort of just this idea that there are still questions that we don't know the answer to. So for example, in my senior design project, I did a small project with Dr. Lusk about qubits. And this was, before the IBM quantum experience was a thing, before commercial quantum computers were a thing. And, Jen can tell a lot more about that field specifically, but that really, it inspired me to keep learning and keep doing research. So I've always been driven by kind of curiosity driven research. So for me, it just felt like this is what I want to do. I want to keep asking questions, and this research path is a way to do that. And so after the master's degree at Cambridge, the PhD was sort of a natural next step for me. So I applied to several different places and ended up attending the University of Maryland in Maryland, and I'm doing my PhD there at the Joint Quantum Institute. And so, yeah, it was the right path for me, just as kind of a book nerd that liked to study and do math.
When you're on the track team here, you always ran uphill, right?
We did run a lot of hills, and I will say, I guess it'll date me a little bit, but when I started at Mines, there was no stadium. We still ran on a cinder track. And so the new, or the nice stadium that exists now was not there at the time. But so we would run hills up and down the hill outside the field house.
So when you were coming back to the United States to pursue graduate studies, I mean, you knew this before you came back, but was it an easy choice to go to the University of Maryland, or did you have other options you were looking at? Because I know a lot of times students think they've got to send out 10 to 12 different applications, which you can do, but then just the paperwork and the logistics of keeping track of all of that can be sort of tough. And Maryland's got a real strong program. Well, not only in physics, but other fields.
Yeah, I mean, I did apply to 10 or 12 places. And there were a few that I didn't get into. I didn't get into UC Santa Barbara. I didn't get into Harvard. I didn't get into, several other places. And then for me, I had been looking, the places that I did get into, I was looking at, my top choices were University of Maryland and the University of California at San Diego. And they're both good programs. But, applying for PhD programs and master's programs, frankly, is a major undertaking. And it takes a lot of research to find the correct, balance of programs. But I picked Maryland because it's one of the largest faculty. And I figured, I could definitely find someone that I can work well with here. And I did. I had a great PhD advisor. And so there are some advantages to larger programs for a PhD. But then again, it was also very dispersed. Like, I didn't get to know that many students in my program. People were working at physically different locations across the state. So there are advantages and disadvantages, but that's why I chose Maryland.
Yeah. Hey, how about for you, Jen?
Yeah, so kind of similar to what Hillary was saying, like the reason why I wanted to, do graduate school after Mines was, felt like I just wanted more physics education. It was, I just really enjoyed learning about physics, and I wanted just like more and more of it. And so I thought, well, I guess I'll get a PhD. And I think too, another reason was I didn't really know exactly what I wanted to do career-wise. And I thought, if I have a PhD, that probably will open up more doors down the road, which I think has been the case. So that was kind of another reason, a little bit longer term view. And then I ended up going to Michigan State in part for like a two-body problem reason. So like my husband, Joseph Glick, which you might know, we got married after graduating Mines. We met there. He's actually my TA. A fun fact. He was a TA for physics too, actually. And we got married after Mines, and then we both went to Michigan State together to do our PhDs in physics. And now we're both at IBM.
Oh my goodness. So now that
Actually,
you've got
can I
your-
just add something? So I also met my husband at Mines as an undergrad. We were on the same senior design team for Dr. Luss group. So you never know what you're going to find.
Oh my goodness. Who is it? Who was it?
Duncan McElfresh, he transferred.
Oh, yes.
Yeah, so he just defended his PhD in computer science.
Uh-oh.
So he left physics, but doing computer science. No.
Oh my goodness.
And
Say hi to
I'll add
Duncan for
too,
us.
I met my husband in Phys One studio.
It's a trend.
He wasn't physics, but yeah.
Oh my goodness. We should have this colloquium again on Valentine's Day. Okay, so now all four of you folks are now on sort of different career paths, taking advantage of that Mines undergraduate education and some of your extra studies you've done afterwards. And so I guess, one of the questions is, why did you actually choose? Hopefully, you made a good choice with your careers. I mean, why did you choose a particular company or organization that you are now working with? And what factors went into that decision? Because I know you've all had options, 1, 2, 3, 4, 5 to choose, career paths. So what was sort of the some of the maybe the top 3 deciding factors that led you to where you are And we'll start with Allie again. We're going in alphabetical order.
Yeah, so one of the things that helped me decide to go to Boom was that it was kind of in line with that small feel that I liked. I was the 56th employee to
Oh my
join the
gosh.
company full time. Boom is super cool because it's cutting edge. There's literally no other company in the world doing the same thing that we're doing. And we are based in Colorado, so that's a big bonus to me. And I get to do some hands-on work as well as some computer science sort of work.
So how many employees now work for Boom? At least 57?
150.
Oh my goodness.
Yeah, it's been cool. I've gotten to see the company triple in size in the time I've been there.
Yeah, pretty neat. Pretty neat. Pretty neat. Yeah, how about for you, Caroline?
Yeah, so I guess as other folks have talked about, just the desire to study physics, the desire to know things at like their most basic level and answer or learn how you answer those very fundamental questions is kind of what attracted me to aerospace. Obviously different from physics in some ways, but space in general has just always been fascinating for me. And so I had a couple of classes that I took at Mines, a couple of experiences that really drove me in that direction. But to get exactly where I am today, I interned, like I mentioned, with Lockheed Martin that one summer. And the prior summer, I was also with Lockheed Martin, but on a different program. And for that summer, I worked on the GPS-3 program, which is a military program. It's our latest batch of GPS satellites that I know several had launched. I don't remember how many, but at the time, none of them had. So I worked on that first summer. The second summer then was OSIRIS-REx, like I talked about, which was a completely different side of aerospace. It's a deep space robotic mission, deep space exploration. So you're going from low Earth orbit to way out in deep space and with a scientifically driven robot. So those were two really different flavors of the industry. And whenever I graduated, I felt like I'd gotten to see both of those and they were both awesome, but I hadn't had any chance to work on the human spaceflight side. And so that is kind of what pushed me toward NASA and specifically Johnson Space Center. It was a hard pill to swallow to move back to Texas from Colorado, but I'm regretting it now as there's no fall colors outside like there could be if I were still there. But I ended up applying to NASA to work as a flight controller for the space station and work more on the human side of things. And so now what I'm doing is completely different from those two internship experiences. It's really different in terms of actual content of what I studied in our degree. But it's yet again another view on the space program. And so what I'm doing now is I'm one of the flight controllers who sits in mission control for the space station. And specifically my team manages all of the cargo and all the operations that relate to scientific and basic human supplies, like everything from toothbrushes to the most critical oxygen regeneration vehicle spare. I mean, these are things that we're tracking and managing. So much different, but ultimately I knew that I wanted to see that other side of aerospace, and NASA felt like at the time the most exciting place to go to do that. And so that's why I pursued the job that I'm in currently.
Do the astronauts still drink that drink called Tang, T-A-N-G, Tang?
I don't know.
They
I
don't.
have to look.
Oh my goodness. Hey, how about for you, Hillary?
Yeah, so I am currently an assistant professor at San Jose State University. San Jose State is one of the founding members of the California State University system. So for folks who aren't familiar, here in California, there's the University of California, which is the big research institutions like Berkeley, Santa Barbara, et cetera. And then there's the California State University system, which are non-PhD granting institutions. And as far as kind of how I got to this point, so after I finished my PhD, I did a research postdoc at Nist in Maryland. So Nist is the National Institutes of Standards and Technology, and there's one right up the road from y'all in Boulder. I'm going to pop the website in the chat actually, because for the students, they have a lot of research, and there's a summer program there called SURF that enables you to do research. It's like an REU. So Nist was a really great agency to be a part of. It's under the Department of Commerce, but they do all kinds of, I was in the quantum measurement division. So they do all kinds of like very basic sciences research, and it's a cool place to be. And so when I finished my postdoctoral appointment, postdocs are typically 2 or 3 years. So mine was 2 years. And as I was getting to the end, I sort of had 3 roads in front of me. One was continue on sort of this research lab track. So that would be like a national lab or NIST position. The second one, the other 2 were both in academia, one being sort of R1 research institutions, and the second one being more teaching focused institutions in terms of where I wanted to apply. So for these sort of 3 tracks, the first thing I decided is that, well, I really miss teaching and I miss working with students. And so the research only experience for me was out in terms of a career, because I sort of, honestly, I looked back a lot at my experience at Mines and I thought I really want to have the chance to pay it forward. Like, I love working with the faculty there and they encourage me so much, and I want to do that for students. And I enjoy planning coursework and teaching. So I decided that. And then the question was, do I want to go for a big research university, or do I want to go for more of a teaching focused institution? And it turns out for me, I ended up finding kind of a middle ground with San Jose State. And so the reason I picked San Jose State specifically in terms of employer is that I really appreciate the mission of the CSU. It's a major driver of upward mobility here in California. So it's very inexpensive relatively, and we educate a lot of first generation students. And so for me, that was an important piece of looking at places to work. And then I also decided that I really wanted a little bit more balance between research and teaching. So here I have typically what's called a 2-2 teaching load. So I teach 2 courses a semester. And then I have a little bit of research, but I don't have a PhD program. So I have some master students that I work with, but no PhD students. So I still get to have freedom in picking my research collaborations and the programs that I want to work on. But there is less resources for me to do research, and that's fine with me. So it's a good balance for me. And one of the projects that I'm really excited about, so you may or may not know that Mines has a quantum engineering program now. It was one of the first ones launched. And I'm working with Professor Carr and some other folks at Mines to help expand that to our students here at San Jose State. So it's very exciting to me to be actually collaborating with folks who were at Mines when I was a student there. And just, it's a small world in physics, so if you stay in academia, you end up running into people that, you've known from before. So that's a really a nice little tidbit as well. But one thing I just want to mention for those who are interested in academic careers is that there's really 100 ways to be a professor. So, some people say, oh, it's really high pressure and you have to go for getting all the grants and doing all the things. And that's true at some departments, but it's not true in others. And every department's different. And so I found a really great home at San Jose State. And there's a lot of different approaches to being a professor.
Good for you. Good for you. Hey, Jen, can you top that?
I'll try. I did prepare a slide, which I'm a little embarrassed to admit. Would it be okay if I shared it?
Yeah, I think you can share the screen as the co-host, can't you?
Yes. Am I the only one who actually prepared a slide? Okay.
I had one, but it's just like where I'm from, so I didn't put it up.
Yeah, mine kind of got covered, so it all works out.
Gotta have that the IBM stuff.
Oh my gosh, look at
I
this.
know, I made
slide.
like a real slide. I don't know, we'll see. So I'll go through this real quickly since we're kind of running out of time, but one thing I want to, because Chuck, you were saying in one of the email threads was like any sort of maybe like advice or like lessons learned to pass on. So I did want to mention that at the end, but one thing I just wanted to mention about like in terms of the career, start of the career path was like when I finished my PhD, or towards the end of it, I was doing theory work, but I really wanted to do something much more sort of applied or maybe industry relevant. And so I was looking at IBM specifically because their quantum program is like this kind of interesting blend of kind of academic research, but also like very much industry focused. So it's this like really nice blending of these two worlds. And I thought like this is probably where I would be very happy sitting, like kind of bridging these two worlds. So that's why I applied to IBM. And I originally applied for sort of the like traditional research staff member position, which a lot of people in IBM research apply to do, theory work on quantum computing. But when I was up in the middle of applying, one of the heads of the quantum program reached out to me and said, hey, we're starting this new team within quantum. It's going to be specifically client facing, doing some like applied research. Would you be interested in joining this? And I thought that sounded really cool. So I said yes. And I was the first member of the team. And so like it was just me and my boss at the beginning, and it was kind of a wild ride. But now we have this pretty big team of researchers similar to myself who are working with clients and working internally on like algorithms and applications for quantum. So that's been a very interesting experience over the last 3 years or so. But in terms of my current job responsibilities, I kind of broke into three things. So, kind of the core of it is like research into quantum algorithms. In particular, my research has been more focused on algorithms for machine learning and optimization problems. And then also, since this is, I joined a client-facing team, I work directly with a whole bunch of organizations that partner with IBM. So I work with their team that they have staffed up, and we work very closely hand in hand on, quantum algorithms research or maybe particular use cases that they're interested in, and we patent things and we publish things. So I've gotten to work with a lot of really great organizations. Lay listed a few here, but there's a whole bunch I've gotten to interact with, which has been a very, very interesting experience too. And then the third part is software, which I didn't really anticipate starting out at IBM, but this has turned into a really big piece of it is, you're doing all this great research, but then can you turn this into like software that other people can use? And so maybe some people here are familiar with Qiskit. It's, the IBM's open source kit for programming quantum computers. So a lot of the work that I do, I program it in Qiskit. And then, so this picture at the bottom, I just wanted to show this because I thought this is such a cool picture. This is just some of the people that I work with. And I wanted to just share that, like, how many different kinds of roles there are in quantum computing. So when I first joined IBM, I had a very myopic view of what quantum was. But there's like a gazillion things that you can do in quantum computing. So like, this is just a few of my fellow female colleagues and what their roles are. So it's a pretty cool area to be in these days, especially I think now it's just like rapidly expanding and lots of different ways to jump in beyond what you might traditionally think you would do. And then if I could impart maybe a few words, like I'm only, maybe 3.5 years out of grad school, but I have learned a ton being in industry. And there's a few things I've really come to appreciate, and I was hoping to be able to pass them along to others in case they found them valuable as well. So one of them is like communication. That cannot be understated. I mean, I've really noticed a distinction in the workplace of like who is able to communicate clearly and who is not, and that like really can propel you forward in the kind of projects that you get to participate in, and how you advance along in your career is like being able to be a very good communicator. And the other thing is really trying to focus on not being a perfectionist. Obviously, look at this slide. I was like, I'm like a perfectionist. Probably shouldn't have spent so much time making this, but like a big emphasis in industry is really delivering things that are valuable either to your team members or to the company or to the community. And it's really not so much about making sure that you're tying up every loose end and everything is perfect. It's just like getting something out there that people find valuable. And I think this kind of feeds into the imposter syndrome thing. I know I personally have struggled with that, and I think a lot of other people do too. Is if you can, kind of just get these things out there and like deliver things, you start building up a track record of things that you've accomplished, and it can help you feel more confident about your abilities to do things in the future. I found that for myself, at least. Another thing is a huge part of what I've discovered is like, you have to find the right people to help you because you cannot do any of this stuff alone. And so one of the biggest things to your success is just finding other people that can help you be successful. So there's, I do these things like randomly meet people for coffee virtually and, just get to know people in my network. Let's see what else I have here. One thing I have also noticed too is it's really important to try to figure out like what exactly it is that you want people to know you for, and sort of try to actively cultivate that, because otherwise it will sort of be decided for you and you might not like what that turns out to be. So making like very conscious effort to try to focus and like grow the things that you think are important for you in your future. And then the last thing is, if you haven't already, I would highly advise getting a whole bunch of mentors and sponsors. Just asking people, even if you don't know them very well. I think that has been a very invaluable tool for just getting feedback and also, having people advocate for you on your behalf as you go through your career. So anyways, that's all I wanted to say. But if you guys want to contact me specifically about like questions about quantum computing and the industry, I have put my emails here. Please feel free to reach out to me. I'd be happy to chat.
I think your little tidbits apply to all of us, whether you're an undergraduate student, a graduate student, faculty, staff.
Checks down.
Yeah, it works pretty good. Oh my gosh, I've got so many other questions I want to ask, but I thought maybe, should we let some of the folks in our audience just toss questions out to you folks? Are you good at answering questions? Yes, I majored in physics at Mines. I love answering questions. Look at that. You see how eager they are? Hey, so if anybody wants to ask a question, just unmute yourself and ask away.
Yeah, hi, this is Chase Harms. I'm currently doing a PhD. And my question is, if you had to say what your biggest regret is in your studies in physics, what would it be?
Ooh.
For me, it would be not learning how to code properly until I started my PhD or in the middle of my PhD. Just like, I don't know. I mean, I'm sure that, coding education has gotten even better, but for me, for some reason, I think computer coding is harder than physics, and it's not. I just have this block, and, you just got to sit down, and sometimes you have to learn things that aren't physics. And the sooner you do that, the better. Also to Jen's points about communication tools and things like that, just learn how to do it and sooner rather than putting it off.
So when you talk about coding, are you referring to a specific programming language or just the overarching idea of coding and using logical structures and
Sort of both. So for me, it was learning Python. I was mostly doing Mathematica as an undergrad, and this was before I think Python was as ubiquitous as it is now. So maybe not as much of a problem, but learning Python, but then also, like learning how programs are meant to be structured, right? Because we don't necessarily think that way as physicists. Like if someone else was to look at your code, like, could they do anything with it? Have you commented things? Have you structured things in a way that that someone else can work with. And, you know, in industry, this is even more important, but it's important in research too. And I learned it very late, not too late, but it took me a while.
That was a good question, Chase.
Thanks.
I'll ask a question if no one else is ready to. So I was interested, I guess this is kind of directed towards Dr. Hurst. I'm looking into graduate programs, kind of PhD programs everywhere, but one thing that I guess I didn't really think about until like a week ago was the possibility of doing a master's before PhD. I know there's several considerations there, but specifically for something overseas, because I feel like a lot of European institutions, like in the Netherlands or the UK, want you to have a master's degree. For you, you mentioned McBride. I was also McBride, and wanting to be abroad. But other than that, in terms of your career path, what was enticing about a master's program instead of, a more direct route to a PhD?
It's a good question. I think for me, I was entertaining the possibility of doing a PhD overseas as well. And in that case, I would have needed to have a master's degree, because you're correct. So most, both on the European continent and even like in Australia, other places, you pretty much, it's structured differently. So they have 3-year undergrad, 2-year masters, et cetera, but you need a master's. So that was one reason. And then for me personally, I wasn't sure if I was totally committed to this theoretical physics thing. And this gave me a way to do it for a year, and see, what it was like in a broader sense. But if you're thinking about enrolling in PhD programs abroad, you basically have to do the master's abroad. But it will probably add some time. So if you're pretty convinced you want to do a PhD, you might as well do it domestically, because you can always do a postdoc abroad, or even go abroad. Like I went abroad during my PhD for 3 months to work with collaborators. So there's lots of other travel opportunities that's not like doing your whole degree abroad.
Okay, thank you. Yeah, that's a good point.
Yeah, lots of possibilities. Hey, I've got a question. I don't know if I should ask it, but I'm going to ask it anyway. Is there anything that you think our physics department could do differently that might help just make us, for lack of a better word, better? And that could be anywhere from, offering new classes or a different way classes are taught, or bringing in, a different cross section of people that we try to bring into both our undergraduate and graduate studies, or just the way we run the department from an administrative standpoint. I mean, I know you don't see this as a student, but you folks are like the voice or voices that we really want to respect and recognize. If there are any suggestions you can give us.
I think one of the things that I really liked that may not actually be part of the curriculum anymore was in field session, we took some tours of different industry facilities. I think that really helps me kind of lean towards aerospace. So I was kind of sad to see that go.
Yeah. And I think we never left a student behind either.
Yeah, no one fell in the reactor that the labs over on Kipling.
Yeah, on
So.
the Federal Center side. Yeah. But yeah, that's something we haven't done with the field session in a couple of years. Just the logistics can be messy. There's always a cost involved, and how do you get a lot of people at one place at the same time? And particularly in the past, probably 2 years, with all the the COVID things has been difficult, but that's definitely something we could think about maybe reinstating.
I think maybe one thing which you guys are already doing since we're here today, but is like more connecting more with the alumni networks. I kind of think, so my sister did her MBA, and there's a huge focus on connecting the current students to the alumni network. And it's been like incredibly valuable in the sense of, just getting through the program, but then also, connecting with internships and then permanent positions after school. And there's a ton of like feedback from there, like alumni giving back, their experience and whatnot. And I think that's a hugely valuable thing. I know you were doing this with the field session earlier. I participated a little bit there too, but yeah, like as much of that as you can do, I think is super helpful for students.
Yeah, it's really impressed me just how generous, our alumni have been just with their time, their energy, and their expertise. And it's just something that, the ones that want to will, and the ones that don't or can't for, with other responsibilities they have, won't be able to. But it's one of those little nuggets, you try to, tell students, reach out. And that's always a very, very difficult first step. But it's been really, really nice to hear some of the relationships that our students have been able to establish just through the generosity of, some of our graduates. So if you have any ideas, I think if the alumni actually had a big vacation, like a big retreat at a nice resort somewhere, and all the expenses were paid for the students and the faculty, that would be a huge opportunity for us all to take advantage of. We just need to find that benefactor.
Yeah, and I think I don't really have any suggestions, more just what I felt like was really useful to continue going with was kind of like Allie. I knew pretty early on that I was more interested in going the industry route than academia, and I felt like there was a healthy balance of both in our program. I know we still did the tours when I did field session, but just in getting the more hands-on skills, and I remember several colloquia with people outside of academics who were coming in to talk, and I felt pretty supported as somebody who wasn't going to go chase a PhD after undergrad. So that like is a very strong memory in my mind of my time at Mines, and yeah, it's helped me a ton, and I think it'd be really great to keep doing it, which it sounds like y'all are.
Yeah, we're all busy in different ways, and it can be tough to find those little moments where we can get together. But if any of you folks or any of your friends that are part of our physics family, want to come out, definitely let us know. However way you might let us know. And we've got Fred Sarazin leading the department right now, Dr. Sarazin, and I'm sure he would be, overly supportive in finding ways to bring more of you folks out for whatever type of visit it might be. Hey, speaking of visits, oh my gosh, it's 5:01. I'm teaching the night session of the advanced physics lab #1 right now, and the students, they're probably knocking on the doors. But if anybody wants to stay on and ask folks questions for a couple of minutes, I can leave the Zoom room open, and we can just sort of have a free-for-all. And yeah, go with that, and then I can come back a little bit later and close everything out. But hey, I think we need to thank Allie and Caroline and Hillary and Jen. I'm clapping. Everybody else is clapping too. You just can't hear it. Yeah, Josh is clapping. I see Josh clapping. But I'll leave the Zoom room open, and then when you four have to take off and leave, just figure, how to leave gracefully. And if anybody else wants to ask any questions, you can. I've got to go run downstairs, and we're going to measure the speed of light today. We don't know what it is. That's why we got to measure it. I've heard it's been pretty quick.
Thanks,
we see.
Chuck.
Appreciate it.
I was gonna say, I see this question from Sean in the chat. I don't know if he's still on the call, about when did you feel that physics was what you wanted to pursue? Is he here?
Oh, he might be. If he's not, we can get the message to him.
I guess my answer to that is, like, there are still some days when I'm just not sure do you ever really know like that you're 100% sure? I don't think so, but as long as you enjoy it more than you don't. I mean, physics is really hard, like sometimes it's just like, I can't figure this problem out. But as long as you enjoy it more than you don't, right?
I agree with that. I think there are still days where I wonder why I decided to do a physics major. But then I think about it a little more and I'm happy with choosing a physics major. And I feel like the things that I learned and was learning during my degree and the people that I met were well worth the effort. And that I really fit in the physics department. For me, it was more of a cultural fit.
Yeah, and I agree with both what Allie and Hillary said. It's like, it's the thing that continually captivated my interest the most. And yeah, there were some not great times, there were some really hard classes, but overall it was just fundamentally the most interesting thing to me of the options. But yeah, I found moving out of school, and I don't know, I agree with Hillary. I don't think you're ever sure always about things, but being sure enough and taking the step forward is oftentimes good enough. That's kind of what I try to do.
This is Ruben Collins. I kind of wanted to ask you guys a question. Hi. In your curriculum, you had what I would call the structured part. That's the thing where you get a grade and lots of times you have a homework due on a regular basis. But there was also sort of an unstructured part for all of you, being a member of SWE, doing summer research. And when I listened to you, it sounded like that unstructured part in a lot of cases sort of set the trajectory of what you're doing now. And so I wondered if you could talk a little bit about the importance of one relative to the other.
I think for me, the structured part helps you learn how to make the unstructured part work. The unstructured part is where you kind of explore and learn what you actually want to do with your physics major. But without the structured part, you don't really know how to organize it correctly. So I think you have to learn the structured part first, so that you are capable of problem solving and figuring out what you want from the unstructured.
Yeah, I'll piggyback off that. I think that was a really good way to say it though, Ali. And for me, I mean, fundamentally I have to know this stuff because now I'm teaching it. And so obviously the structured part had utility in that way. I think where unstructured activities has really helped me is almost in like the project management sense of doing life. Like there are instances when I needed to organize a workshop, or now I need to figure out how to split my time between applying for grants and teaching and things like that. And being part of SWE actually really helped me with that because it's a big organization and we had to do a lot of work. And so like I talk with folks now who've never organized something, and in some sense I had already done that. Like I knew, oh, you need to figure out food, you need to reserve a room, you need to do this and this. And I know that comes up in industry jobs as well. And that's where the unstructured things really helped me, was just kind of like managing life, I guess. Whereas obviously you need the actual physics knowledge to do the physics.
Yeah, and I think essentially what Ali said, like the structured part gives you the basis from which to work to do all the unstructured things you're going to go do. And that was really true at Mines with courses and then transitioning into projects. But I've harkened back to just the thought process even that I went through for whether it was a particular project or like a class's way that taught me to think in industry and projects that I've had at work. So I think just laying that foundation for how you approach problems and how you organize things, like Ali said, has been hugely beneficial to me.
I think one of the things that worries me sometimes is that it's possible to get a degree without doing anything unstructured. I mean, you know, you get the grades, you graduate, but it seems like you miss quite a bit if you don't participate in those.
I think that epics, is epics still a thing?
Yeah.
Epics and senior design too are one way that kind of everybody has to see that. So I remember senior design being hugely helpful. Like we had like the hour class a week or something where we were learning like how to write reports and how to do literature search and stuff. And that was a bit more unstructured in that you had to do it for your project. So that was really helpful and it was part of the curriculum.
Thank you, guys.
Thanks for having me. I have to step off. Anyone has more questions about Boom or my physics transition to industry, feel free to contact me anytime.
Looks like we've kind of reached the end of questions.
I think I may be the last faculty member left on the screen, so I'm going to take it upon myself to thank you and to free us all up so that we can go about our unstructured lives.
Hey, do you want to say hi to the advanced lab people? Advanced lab people, say hi to the gang.
Hey, y'all.
See how happy they are? They've all passed advanced lab. Oh, these people on the computer. Hey, thank you. We'll be in touch.
Thank you so much.
Thanks,
Thank you so much. Great seeing everyone.
Thank you, Jen. Thank you, Hillary. Thank you, Caroline. Thank you, Allie. She's already left.
Y'all have a great evening. Thank you.
Take care.
Bye.
Bye.
Bye.